Hello students, here you can see two types of class intervals. One is discrete class interval. Here I'm just this lesson just belongs to class intervals, two types of class intervals. First we are going to discuss a discrete. Here 0 to 9 is one class, 10 to 19 another class, 20 to 29 is another class, 30 to 39 is another class. If you observe this class interval, here you can see 0 to 10, 10 to 20, 20 to 30, 30 to 40. Here the lower limit of one class is equal to the upper limit of the next class. Lower limit of one class is equal to the upper limit of the next class. Lower limit of one class is equal to the upper limit of another class. So this is a continuous class interval. This is a discrete separation. There is no common number between one class to the another class. So here you can observe there are the two types of class intervals: continuous class interval, discrete class interval. Here it will cut here and another new number will come. So likewise this class interval can form, that is another one. That's all. Here we have a 20 numbers, tally and frequency. Same 20 numbers are here. And what is the difference? How can we take same 20 numbers? Here you can take 0 up to 9 only. 10 should not be taken in this class. If the 10 comes, you have to write down here in the next class. Here 16 belongs to second class. 10 belongs to where you have to write. 10 is showing in the two places where we have to write here in or here. Here we have to write 10 belongs to second class. Okay, so here you can take, but it is not visible in the mind. You can take 0 to 9 only. Here you can take 10 to 19 only. 20, when the 20 comes, you have to write down in the next class. So you will take only lower limit, you won't take upper limit. So likewise you can frame, but this is the same pattern when you compare with this one. Both are same. Here the numbers are clear, so that we can take lower limit and upper limit here. Here you can take lower limit and upper limit. Both the limits you can take in discrete class interval. In continuous class interval, you will take only lower limits, but you will not take upper limits. Okay, that's all. Clear? Now, how to convert discrete class interval into continuous class interval? Now there is a gap, there is no connection, that is no same number, but different numbers are here. If you want to convert discrete to continuous, you have to reduce a 0.5 to lower limit. 0.5 to 9 is here, then you can write down 9.5. This is 0 less half, that means negative 0.5. You have to reduce 0.5 to all the lower limits. You have to increase 0.5 to all upper limits. Then we will see 9 becomes 9.5. Now 10 should be decreased as 9.5 dash. 19 should be increased 19.5. Clear? Again 20 should be decreased 19.5, and 29 can be written as 29.5, and 30 can be written as decreased 0.5, that is 29.5, and 39 can be increased 39.5. Likewise, you have to prepare. If you see 9.5, 19.5, 29.5. Now, this becomes continuous class interval. If you make tally, it will be the same. So, I want to repeat. Here, we have continuous class interval. In the mind, you can take up to 9, 10 you will not take. So, you will take only lower limits, upper limit will not take. But here you will write and you will do the same things, and you can take lower limit and upper limit, both limits you can take for the tally. Next, if you want to convert discrete to continuous, reduce 0.5 to all the lower limits, increase 0.5 to all upper limits, so that the numbers will be equal and it converts into continuous class interval. That's all.